everyone. In this video we're going to look at annuities and perpetuities. So just remember, perpetuities are just an example of an annuity, nothing completely different, just slightly different. So I might scroll back up to why we're covering these here, because we do combine linear and geometric sequences with annuities. So in a previous video we've covered investments where you've got compound interest and reducing balance loans, which are also compound interest. But then we've also got annuities and perpetuities. So an annuity is kind of like a special type of investment. You do give money to the bank. That's why your present value is negative, but you then get repayments back from the bank. So a good example is when you retire, you might get your super, so your superannuation. So when you start working, your employer or yourself, you would put money into your super account. So when you retire, you live off that super as opposed to continually working until the day you die. So the investment is like your super, and then the money you get is your repayments from, your super fund. Or if you had an investment, a bank. Another good example of an annuity is maybe like a scholarship. So a school may have had a past student who left a lot of money to that school and said, I want to set up a scholarship fund for students who are musically gifted, and therefore, you might have this investment amount, and that is funded from that scholarship is funded from that investment. So the payments come from that investment. So it does earn interest, it earns money, but then you get repayments that pay for the scholarship. A perpetuity is a special type of annuity, but it never goes down in value. So if we just go and have a look at these two couples. So on the left, they have an annuity. So basically, they keep getting those repayments until the investment is zero. All right, so they put their investment into the bank and then they get repayments back from the bank, but they keep going until it's zero, basically. Whereas a perpetuity is slightly different, still money that goes into the bank, but your payment goes on forever. It never actually ends. So your perpetuity never goes below its initial investment amount. So that's the main difference between the two. So if I just scroll down to have a look at this on the financial solver. So a good example, good, bad or ugly, is $150,000 invested for 10 years, earning 5% interest per annum, compounding monthly. All right, so I've just set up that scenario to show you the difference between an annuity and a perpetuity. All right, so it's 10 years and we're doing it monthly, so 10 times 12, that's where the 120 comes from. We always put in our annual interest rate, so for this one it's 5. Now, it's money going into the bank because it's an investment, so they're both negative. But this is where the changes happen. So for your payments, your PMT, you're getting that money, that's why it's positive. So an annuity, you can see it's much higher than what it is for a perpetuity. And that's because for a perpetuity, you're basically only earning the interest, you're receiving the interest. All right, so every month you're getting $625, whereas if it was an annuity, you'd be getting $1,590.98. So big difference in repayments, but a perpetuity obviously is going to last forever, right? And there will be perpetuities out there, but if you had a perpetuity, obviously you're not going to live forever, so you might not actually, want a perpetuity, but maybe, if you were setting up some sort of fund, maybe for your children and your children's children and your children's children's children, then you might have a perpetuity. So it goes on forever. Whereas an annuity, maybe you just want to, live for the next 20 years, or in this case, 10 years. And that's, just under $1,591 per month by investing that. So future value is 0, but with a perpetuity, you can see exactly the same. Now, on your exams and in your SACs, obviously this is such a small part, but I just think such an easy part, such an easy thing. And the thing is, students see the word perpetuity, maybe even annuity, when they cover this topic, and then probably give it no more thought until the exam, and there's often a question on there. So if you understand that perpetuities, the future value is always equal to your present value, then you're good to go. All right, so that's the main difference between a perpetuity and an annuity, and it's all written there. All right, so let's have a look at some questions. Okay, whoops. Going to do amortization tables in a different video. All right, sorry, I thought I had all this set up. All right, Helen invests $40,000 in an annuity paying interest at the rate of 6% per annum. All right, let's highlight things, not hire them. Annuity, and 6% per annum. They'll usually always give you the annual interest rate and then tell you when it's going to be compounding. So in this case, it's compounding quarterly. She receives a payment of $10,380 each quarter. All right, and we're going to be doing a recurrence relation in terms of V. So remember, it's not always going to be V, it can be a different letter. So just, don't be surprised if you do a past exam question and they've used the letter A or B. All right, same thing. All right, so they've kind of been kind and given us the recurrence relation. It is also in your notes. So if I just scroll back up to the top one. All right, modeling an annuity. So here we go. If you're doing a perpetuity, your common difference is just your interest amount. So when we do some perpetuity questions, you'll see that. All right, so perpetuities, same recurrence relation. You might just need to think about how the common difference is different. All right, let's go back to the question. So V0, your starting amount. Remember, it's always positive. So even though it goes to the bank, negative on financial solver, it's not negative there. Vn plus 1. Now your common ratio, let's calculate that. So 1 plus 6 over 100. What am I doing? 100 times P is 4. Sorry, I was just thinking of something else, got a little bit distracted. Times Vn minus your repayments. All right, so let's just tidy that part up. So 1 plus 6 over 100 times 4, 1.015. Oops, now make sure if a letter doesn't look like a number, or a letter, probably more so a number, rewrite it. All right, the number of times I've seen numbers on exams and you're just like, what is that? I don't know. If I don't know what it is, then I can't assume what it is and therefore it's wrong. All right, use the recurrence relation to determine the balance of the annuity after 3 quarters. Round your answer to the nearest cent. Now, this question isn't a show that question, but I'm going to treat it as a show that question, which is quite common in the exams because they don't want you to just use, finance solver, which you could do for this one, but actually show you understand what a recurrence relation is or how it works. So I'm going to do that. All right, I'm going to treat this like a show that question. Now, in a show that question, you've got to show V1, V2, V3. We've already got V0, all right, written there. You can write it again. It wasn't given to us in the question, so I'm going to write it again here because it is a separate question. If it was given to you in the stem of the question, you wouldn't really need to write it. All right, so 1.015 times the previous value minus 10,380. All right. So 1.015 times 4123 minus 10,380. All right, so there's the first one. And then we do the same thing for V2. So So 1.015 times 30220 minus 10380. So, and I'm going to put the answer there just because I'm running out of room. And Siri is just coming up on my phone. Don't know whether you can hear Siri, but she's talking to me. All right, so I'm just going to, oh gosh, sorry. All right, so I'm just going to delete that and put in the previous one. So 20293. Now, all along do to 2 decimal places as well. So you notice on the calculator it just had 0.3. Do put 0.30. Make sure any rounding in a show that question is correct. And because we've already defined V2, you can write V2 there as well. So I'm just going to do that just to save time. All right, so I'm going to highlight this, drag it down. All right, and get rid of that. And then I can just drag this one down here. All right, 10217. And then we've got to round that. So 6995, so it does round to 70. All right, so make sure you do that. 70 cents. And I've made a mistake, haven't I? I feel like I have. Oh no, because we're getting so much money. Yeah, because she's getting $10,380 per quarter. I was wondering why it went down so quickly. So she's invested $40,000 in an annuity, but is withdrawing a lot of money each quarter. So not really probably earning much interest there. But anyway, we're not going to judge what Helen does with her money. Moving on now to Jeff. All right, Jeff invests $1 million, wow, in an annuity and receives regular monthly payment. So it's monthly. The balance of the annuity in dollars after n months, oh, finally, a different letter, AN, can be modeled by a recurrence relation. So given the recurrence relation there, state the initial value of the annuity. So that's $1 million. State the payment that Jeff receives each month. So I might just, so there's your initial value. There's the repayment. It's $4,000, not negative 4,000. It's 4,000 he receives. Calculate the annual compound interest rate. All right, so remember your R, your common ratio, is calculated by 1 plus R over 100 times per, which is, what was it again, monthly, so 12. All right, so let's, oh, actually, let me write the formula because I didn't substitute anything else in. Let's put P there. All right, so R, capital R, is 1.0024. 1 plus lowercase r is what we're calculating, the interest rate, and P is 12 because it was monthly. So we can just do solve on the calculator. All right, so shift divide. So I'm just going to use X 100. Oops, didn't go down. 100 times 12, and we get 2.88. So the annual interest rate is 2.88%. Calculate the balance of this annuity after 2 months. All right, so you would, it's very similar to what we just did before. So you go 1.0024, and you could put this in your sequence one as well. Actually, I might do that because I wouldn't mind showing you something else. So let's just go there. All right, so put another 0 in. So annoying when it, there we go. I'm going to replace it with a 4. And it's minus 4,000. And the initial amount was 1 million. So 1, 2, 3, yeah, there we go. Just make sure we've got 6 zeros. All right, and you're getting all these, you're probably thinking, oh my gosh, nah, freaking out. All right, what I might just quickly show you is you can go to settings, and maybe, oh, it is in normal too. All right, that's annoying. Okay, so these numbers are obviously too big for the table. That's why you've got the E, but we can just press on it and it gives us the number. So don't stress too much. So there it is after 2 months. So there it is initially, your 1 million after 1 month, and then after 2 months. So you can do your iterations that way as well. You know, you've got your answer there. So if you were doing, like I did before in this, showing all this, instead of doing that all on your calculator, you could just say, all right, well, A0 has already been defined, but I would write it again. 1, 2, 3, 4, 5, 6. All right, then A1 is 1.0024 times A0. You don't have to write the 1 million, minus 4,000. And then A2 is 1.0024 times A1. Whoops, didn't want an equal sign, I want a minus sign. And then we can just get it straight from those values straight from the calculator screen. All right, so there's A1 and there's A2. So you with your writing your iterations, so in the previous question, your V1, V2, and V3, it probably would be easier just to have them all there instead of typing them all in. I don't know, much of a muchness really on your calculator. All right, and you saw those values on the calculator, so if you need to get them again, there was your, although you should be doing it on your own calculator, guys, and there it is for 2. All right, moving along. We're doing another annuity, so it's probably a different type of question, so we'll do it again. Esme invests $100,000 into an annuity and receives regular monthly payments. The balance of the annuity in dollars after n months, so this time we're using the letter E for probably Esme, and we've got the recurrence relation. So investing $100,000 and she's receiving $18,400, right, which is question A. So there's your answer for question A, $18,400. Find the annual interest rate. So we've got R is equal to 1 plus R over 100 times P, and you're just substituting in for that. All right, so we've done that already. You can probably do that on your own. All right, so I'd pause it and then just do it on your own. At some point in the future, the annuity will have a balance that is lower than the monthly payment amount. So the balance would go go under 18,400. What is the balance of the annuity when it first falls below the monthly amount payment? So I'd probably do this on the sequence screen just because it's so easy to see. All right, so let's drop a 0 here and change this to 55 and then 18, and we are rid of one of the zeros. You want to go, please, 0? There we go, 18,400. So when we get it up on the table, all right, so we want to see when it first goes below 18,400. So there it is at 28,000. And then it's gone to $9,762. So the next one is obviously going to be negative because you don't have enough to have that payment. So after, so 5 years after the investment, you're not going to have enough money to get that 18,400. You're only going to have enough to get $9,762.84. So what is the balance of the annuity when it first falls below the monthly payment amount? So there it is. So the 9,762.84. Is that the only question we had? Cool. All right. I know I didn't do much with that, but we need to get onto the perpetuity questions and make sure this video isn't too long. I'm trying to aim for 30 minutes for each of these. All right. Donna sold her cafe business for $720,000 and invested it into a perpetuity. The perpetuity earns an interest rate of 3.6% per annum. Interest is calculated and paid monthly. So what that means is whatever interest Donna receives on that money is what she gets. She doesn't get anything else. Whereas with an annuity, you can set what amount you want to receive until it goes to zero. Whereas with a perpetuity, it depends on what your interest rate is and how much interest you receive. All right, what monthly payment will Donna receive from this investment? So we just need to do, so she's getting it monthly. So we can do this just on Financial Solver, which would probably be easier actually. I mean, you don't have to do it on Financial Solver, but I'm going to do it on Financial Solver. So let's clear it. Okay, so her N, actually it's probably good we're doing this here because we're just going to do 1, all right? Because remember it stays the same, so you don't have to have any value of N. It's actually probably going to be harder if you do a different value of N. 3.6. Now, your present value, remember it's an investment. So perpetuity is a type of annuity, so it's still going to the bank. There's your $720,000. The payment is what we want, all right? What monthly payment will Donna get? So we'll leave that blank for now. Her future value, because she's getting that money back, oops, it's got to be positive 720,000. Right, she's going to get that money. So at any time, Donna can say, yeah, you know what, I'm going to try another business. Maybe not a cafe business, maybe a dog grooming business. So I'm going to take that $720,000 back. Thanks, guys. And the periods is 12. It's monthly. Remember, those two values are going to be the same. So she's going to receive each month $2,160. Now, what you could have done, just because people might be like, oh, that's such a long way of doing it. I realize there is more than one way to do something. All right. So 3.6 is our annual interest rate. Let's divide that by 12. So our monthly interest rate is 0.3%. So we just need to do 0.3%. So I'm just going to turn that from a percentage into a decimal and multiply that by our 720,000. Right, and we get the same amount. So you can see why I like the Finance Solver. It prompts you and you might be a little bit confused about what goes where if you're doing it that way. But for those of you who are really confident with financial maths, you probably just do it that way. All right, after 3 years, the interest rate for the perpetuity increases. Describe whether Donna's monthly repayment will increase, decrease, or stay the same. Well, it definitely will not stay the same, so the interest rate does change. If it increases, then her payment is also going to increase. But let's say we didn't realize that. So let's go back to our Financial Solver and let's just actually change it. So presently she's getting $2,160. Let's just change it. It's got to increase. Let's just change it to 4 and see what happens. So we don't need to delete it, but I'll delete it anyway. Just after 3, it doesn't matter what the time period is, makes no difference. All right, because the amount hasn't gone down, and there you can see she gets 2,400. So a question like this could be on an exam. With a perpetuity, it doesn't matter how long. It could have said after 300 years. It doesn't actually matter. Donna will still have that $720,000 in the bank. All right, so it doesn't matter. She's just living off the interest. All right, and then we've got one more question to go, guys. Omar inherits $720,000 and splits the money between a perpetuity and an annuity investment. The perpetuity pays $2,340. Let me highlight some things. All right, so we're doing, whoops, there we go, and splitting, I don't know whether it's evenly, so let's not assume so until we've, well, let's not assume, but we will if we have to. The perpetuity pays $2,340 each month based on an interest rate of 5.2% per annum, that compounds monthly. The annuity has an interest rate of 4.8% per annum, that compounds monthly. Calculate how much Omar invested in the perpetuity. Okay, so it's not the same amount. Sorry, I just thought I heard a car come up the driveway. All right, so we need to know how much he initially invested. So it's not a 50-50 split between the annuity and the perpetuity. So what is going to give it away is this monthly amount, right? That $2,340. So pretty similar to what I did before on the calculator with the previous question, not there on our main screen. All right, so what I was doing here, because I don't think you can do it on Financial Solver. So anyway, I would do it here. So our annual interest rate was 5.2 and it's compounding monthly, so we're going to divide that by 12. So 5.2 divided by 12. All right, let me leave that as a decimal, not a decimal, sorry, a fraction. So 13 over 30. Whoops. And then, so I'm just writing the exact value because it was decimal places and we want to really be exact. So if I left it on my calculator, I would be fine with that. I'm just going to leave it as 13 over 30 if I ever have to have the exact value again. All right, so that is per month. So I'm going to change that now to a decimal. So I'm going to divide by 100. All right, if I wanted that as a fraction, I can do 13 over 30 divided by 100. It's going to be 30 over 3,000. All right, just to keep it in the exact form, but it's in your calculator anyway. So I'm just writing it there, but I can't be bothered writing all the 3s. Okay, so we've got to take that amount of, so let's do solve. So we're going to solve. We don't know what the initial amount is, so we'll call that X. So 13 over 300 times our original amount is equal to 2,340. So initially invested $540,000. One more zero. So what I've done here is the monthly interest rate, all right, as a percentage. Here is the same thing, but as a decimal. And then we've just, so basically we've done 5.2 over 12 divided by 100, and then times some value. Our initial value is equal to 2340. So this part here is what this is, right? If you're wondering where everything came from. So 540,000. State how much is initially invested in the annuity. So we can do the same thing for that. So 4.8% also. So let's do this in one go. So 4.8% divided by 12 to make it turn it into monthly, and then multiply it by 100, divide by 100 to turn it into a decimal as opposed to a percentage, because it's currently in a percentage. And that's times your initial value. So we'll call that PV. I called it X before because that's what we put into the calculator. And there's an interest rate that compounds monthly. Oh, silly Billy, we don't have to do it the same way. Probably thinking, what is she doing? I'm making it too complicated, because we didn't know what the payment amount was, but we do know, which I missed, is that he inherited $920,000. So in the annuity is just the difference between the two, complicating things. And I knew that because I didn't have the payment for the annuity. So that's why I went back and thought, well, I have to do this a different way. Minus 540,000. Okay, so $380,000 is in the annuity. Omar realizes that he only needs $2,000 from his perpetuity each month, and so he adds $340 as an additional payment into the annuity each additional month. Find the value of the annuity investment after 3 years. All right, so the perpetuity, so basically what's happening is Omar's getting the $2,340 from the perpetuity, but he's only keeping $2,000 of it, and the $340 he's putting into the annuity. All right, and doesn't say that, so he's adding money to his annuity, but he's not taking any money from the annuity. Okay, so it's just an investment. All right, so this is slightly different because even though it's an annuity investment, we're not taking out money, we're only adding in money. So got to be careful when you're looking at this here to understand the difference. So let me go to my guys down here. So with our annuity, this would be a payment given to you, but we're making payments to the bank, so just make sure your payment is negative there. All right, so let's get the calc happening. All right, so financial, let's clear everything. All right, so let me just read it. How long? 3 years. So 3 months. Have they had it any time? Okay, so he's realized this after no time, I'm assuming, unless I've missed part of the question. All right, so no time has passed. So we're assuming that the initial value is still $380,000. All right, so 3 years, but it's monthly, so it's 3 times 12. You can write 36 there, but let's say you had a multiplication that you couldn't easily do. 4.8. All right, so it's an investment, so it's got to be negative, so 380,000. Now, the payments, he's making those payments to the bank, so it's also going to be negative. The future value we've got to work out, and then we've got payments. All right. So he, after 3 years, ends up with $451,866.88. All right, so you can write that value down. So an annuity, he should be receiving this money. This is basically just an investment account because the annuity should be paying him money as well, instead of him just adding money to the annuity. All right, so that's it. The next video we'll look at amortization tables. All right, bye guys.